Okay. Well, it's 10 a.m. Let's see what happens over the next hour. Whoa. What's going on here? A new thing at the bottom. What's going on? Today, I'm going to be talking about tlp-stress. For those of you that are not aware, about, I don't know, back when I was at the last pickle, I can't even remember how long ago this was, like 5-6 years ago, something like that. I was working on a ton of performance-related problems. In fact, that's the thing that I was, I was kind of building that up in life and getting really into understanding performance in Cassandra. I was actually really into performance before Cassandra, starting about 20 years ago when I used to run MySQL on like boxes with only 4 gigs of RAM. I got really into query tuning and performance optimizations and really understanding kind of what was going on at the system level. And then when I started using Cassandra, one of the things that kind of bothered me was that out of the box, the configurations that we ship with the project, they're great for your laptop, but they're really, really not good for production. And I was working just on a lot of clusters at the last pickle where folks had performance problems, and I started to realize that the way that we go about testing performance with Cassandra isn't really that great. So that kind of led me into this conundrum where I was like, okay, what's the best way to benchmark this? Like, what do we actually need? And it started out by me writing kind of like a simple program. It was actually just it wasn't, I wouldn't even consider it like a benchmarking thing, even though it is, but it wasn't flexible at all. It was literally just like one type of workload. You could like hit Cassandra with a key value workload, and I was like, all right, I'm gonna work with this. And so I built that out, and then I kind of just started abstracting things and turned it into this like engine that was all of a sudden pluggable, and then all the other components I made pluggable. And recently I've readopted the project. I had a customer that needed some help understanding what was going on, what their systems could be capable of, and so they sponsored some really interesting work. Now we can actually tell it. I have a specific latency, and it will go ahead and find the latency. I'm getting ahead of myself. I've got some slides here. I love slides. If you know anything about me and kind of the stuff I've done before, I love doing slides. These are not the fun ones that you may be used to if you've seen a lot of my stuff in the past. But it's okay. It's just to get the ideas across, just to help me explain myself. So let's take a look. Okay. So I don't know if any of you have used MySQL in the past, but one of the things that I really liked that they kind of had as a like a fundamental principle of the project was you need to be able to get up and running in about 15 minutes after you decide that you're going to get started, right? You download the project, you start it up, you create some users, you create some tables. It's only 15 minutes. To me, it's really important. There shouldn't be a huge amount of setup. Like, you shouldn't have to keep a lot of information in your head, and most things should just be done for you. Like, we have enough stuff to keep track of without making our benchmarking tooling like a thing that we need to become experts in. This is actually not a thing that we should have to become experts in unless you're like writing it or you're contributing to it or you're doing something that actually is, taking some sort of like point of view where benchmarking is a significant part of your life. Like, benchmarking is obviously a significant part of my life. I'm doing it now. It's part of my career. I do it all the time, but I actually forget how this stuff works sometimes. So it's nice for me to actually have this. So the idea was, let's make this the easiest benchmarking tool in the world. Okay, and there's a few things that I think uh, make it work. No, wrong slide. What is going on here? Did I get my slides out of order? Oh, I guess I did. I messed up my keyboard shortcuts. So, why not Cassandra stress? I think is a pretty reasonable question that we should ask. And I got to be honest with you, I don't love Cassandra stress. I think it's a really hard to use tool. I think there's too much boilerplate that you have to write down. I think you have to know too much. If you're using it regularly, maybe you don't feel that way, but I personally don't really feel like I should have to work with some new configuration file format that I don't understand. Like it doesn't lend itself towards working incrementally to solve a problem. Like when we take a look at this, for example, so cool, we can see the key space definition and table definition, and then there's this like column spec thing. If you don't really use this a lot, are you going to know what this is? It's a little weird. I don't know. Right, you just have to write all this stuff. I mean, just looking at this, like you have to write all this stuff out every time. Like, I don't know who would know this without a reference. It's too much. So, rage face, obviously. Now, the thing that I found when working with Cassandra is that there's really not that many access patterns because we don't have the ability to, we're mostly thinking about accessing data in a single partition. We're either, reading to one part, like within a partition, we're reading and writing to one row, or maybe we're doing batches. We might be doing lightweight transactions. We might be reading to the middle of it. We might be deleting some stuff. But like the reality is that we are dealing with what is essentially a hash map. Okay. And so there's just not that many operations that you can do on this. So it seems really silly to me to have to write a ton of boilerplate in order to do a load test. Like, if I have to spend an hour writing a test, that doesn't make any sense. Like these things just are. It's really strange to me. So what I built, tlp-stress, what I've built is a benchmarking tool that includes the benchmarks with them. Now, there are other tools that kind of do this, like YCSB has an option, like ships with some workloads in it, but I haven't looked at YCSB in a while, so maybe they've improved some things. But the last time I looked at YCSB, they used Cassandra so poorly and so incorrectly that the numbers that you get out of it didn't make any sense. Like they were doing their own pooling of Cassandra clients, even though the driver does its own pooling underneath. They're literally creating multiple instances of the client and then trying to do their own pooling with it. So it was an incredibly inefficient process. So I truly hated it. And the data models that they had themselves were also kind of whatever. Like it just didn't give me what I wanted. So I basically just decided I would just ship a benchmarking tool with all the benchmarks built in. And the cool thing about doing this is that you get to put reasonable defaults on everything. So for example, like, if you want to run a key value type workload where you have a table with a simple key and a value, no clustering columns. This is really easy. You literally just tlp-stress run key value. The reason why I like this is I think should be obvious. There's almost nothing that you have to think about. But there is definitely going to be the case where you might want to do something other than this. Like, what if the size of the data isn't, the default size of the data is not correct. What do we do there? Or how long does this test even run for? Right? Like, these are interesting questions. Well, we can actually address both of those very, very trivially. tlp-stress provides a -d flag for duration, so it will just last as long as you need it to do. And then we can also override the value or the parameters that generate the actual values that are being associated with individual fields. So within the machinery of tlp-stress, like these individual field names actually get registered with these generators. Each one has its own type of generator, and you can dynamically change the generator on the fly. So you can do, this right here. You can see field key value dot key equals random 50 to 500. The -- field, the thing that goes after that key value right there, that's the name of the table. And then the dot key is the name of the field. So it's field, -- field, table dot, whatever the field name you want. Actually, that one we wouldn't want to use key there. We'd actually want to use value there. I believe key may be registered. It doesn't matter. Pretend that says value. Pretend I did it right. So I'm just going to move away from this. I'm going to just drop straight into my terminal because I've already got a stress test running. And can we see that? Yeah. Okay, so I've got a running stress test here. And you can see how we're doing right around 5,000 queries per second. And we're doing pretty good. Like, for the most part, we've got low latency around here. There might have been like a GC pause or something here, or not sure actually what that was. But anyway, not important. Let's just take a look and run this rerun. Take a look at how we're going to run this. So, and let's just change this to, we'll change this to value. Field key value dot value equals random 50 to 500, duration 1 hour. That's cool. We'll also do -- drop. -- drop will go ahead and drop the table, drop the entire key space first. So you don't want to do -- drop. Just give a quick demo here, and then I'm going to show the help, so you can see how easy this is to use. So let's just pretend that you want to benchmark this key value type workload. What you would normally do would be you would tlp-stress run key value, you take a look at what it does, and then you essentially get to tweak the parameters that run the job. So here, and this is kind of interesting. This is a weird thing that I'm not 100% sure why this happens. I recently switched the internals over to use a queuing system. So this is actually now it has a scheduler built in. It didn't used to have a scheduler. So now the scheduler will see what it'll tell you right here, starting with fixed rate scheduler at 5,000 requests per second. So it's just sitting there pushing everything into a queue. I haven't profiled this yet. It may actually be, it could be due to the implementation of the queuing thing that I picked. I believe I'm using like an array backed queue or something like that. Doesn't really matter right now. But as it warms up, as it gets past like, what's this, 30 seconds, you can see it drops into like what you'd expect it to look like. So let's just take a look here. Oops. Okay. So just looking at the parameters for TLP stress, you can see that you can change your consistency level. You can switch up compaction, compression. This is actually kind of a fun one. This coordinator only mode. There was a guy, Eric Lubo, years ago who was big into running Cassandra with join ring false, set to false, and essentially that it doesn't participate in the data, but it acts just as a coordinator. So you can put a coordinator either on your node and connect to that local node, and then it does the coordination. I was curious if that actually helped anything. It might be able to, but I went for a different route. I think you can tune things differently and get the same effect. You know, you can like actually change things that are going on in the driver too. So this is actually using the old DataStax driver. I need to switch it now that we're publishing our own driver. I need to upgrade it to the Apache one. Anyway, you can run additional CQL. So let's suppose that you wanted to like run this key value workload, but create a secondary index on the value field. You could do that. You would just pass this, and then you would pass in, the CQL to create an index. You know, you can write out your metrics to CSV, so when you're done, you can plot everything. You can bring it into whatever you want. I actually wrote something recently that took the CSV data and loaded it into a pandas data frame and then graphed it. So you can get some useful information there. Picking your DCs, how many tombstones you want. What percentage of your workload should be tombstones? Duration for -D, you've already seen this field thing. HDR histograms. These are pretty cool. HDR histograms will dump out the histogram data, and then you can drop them into this histogram website. I should probably add that into the help text, how to do that. But you can shit. Hold on. Okay. Sorry about that. Someone at my door. Wrong screen here, terminal. Anyway, the point here. Anyway, the entire point of all this is just. Oh, this is where we are. Max RLAT and max WLAT. Clearly, I need to add help for max WLAT, but you can do stuff like this. This is pretty cool. Let's see now. We'll just run this for a minute. Max RLAT. Let's just say it's max readlat will be 20. Max RLAT will be 30. And then this will actually, we want this to run for a little bit longer. I'm just going to run this while I talk about this. See, and then I messed it up. Okay, so this is going to go ahead and run, and I'm going to talk about what's going on while this is running. Max RLAT and max LLAT are settings See this right here? This is different. Enabling latency optimizer. So what this does is this allows you to specify what your maximum read and write latencies are, and it will adjust the rate limiter and change the throughput so that you can try to find the maximum throughput for your instances or for your cluster, based on the response time that you're getting back at the driver level. It's actually pretty it's pretty cool. Here, let me give you a little more space on this. So like here, you can see that this number is going up right now. So this is now up at around, what's this, 5,400, 5,500. So these numbers are going to keep going up and up until it reaches a point where we've hit our maximum latency number. So I'm just going to, real quick, I'm going to jump into here. I'm going to do a separate video on TLP cluster because I think that there's a lot of really interesting stuff in here, but TLP cluster will set up an environment for you. It actually right now is set up where you can use Packer to create an image that has like all this stuff on it that you'll need, including Cassandra itself, multiple images. And I need to get it to the point where it can run, where it gets a build of tlp-stress. That's a long story. But anyway, so that's what I used to create this over here. And then when you do source, that right there, you get this nice little alias. So you can do C0, 1, 2, 3, 4. So all the instances have, what's it called? They all have aliases. So the aliases are really convenient. So if I do C0, I just get SSH'd into this box. Okay, so this thing. So now you can see that this is moved up to 7,500 requests a second. So it started at like 5,000. Now it's 7,500. Yeah, now it's 8,000. So these numbers keep going up, and so here we have, you can see when we watch the tail from the stress log, you can see as it's making its adjustments. As long as if the latency number is way off what you've specified, then it basically will use this. It calculates this adjustment factor, which is larger as you get further away, but it also is capped a little bit. So it's kind of like it'll make up to like I think maybe a 20% adjustment or like a 10% adjustment or something like that, but it doesn't do it that often. Like this is a 5% adjustment factor 105 right there. So we have our latency target is here. We have our current rate limit is at 10,000 right now. And so, we originally, when we started this, we said max 20 and 30. So 20 for writes, 30 for reads. And, this has gone over a little bit. So you can see where it would adjust. See reducing throughput by 10%. So now we're over max latency, so it's going to go ahead and bring it down. So what actually happens in here is you end up with this kind of like, it looks kind of like a sine wave, and it'll just be like hovering around your expected latency. It's not going to be perfect. It can't be perfect. Cassandra isn't, especially with one node, because a GC pause of 200 milliseconds or something is going to throw off everything. And this is not a tuned environment, by the way. This is actually, let's get out of here. So which one am I running? 3-0. I think this might be 3.11. Install. Okay, gotta install Python in here. So we'll wait while it does that. There we go. Yeah, there we go. So let's just take a look here. Yep. So this is why I was saying, remember before I mentioned that the key isn't, you can't make adjustments to the key. And the reason for that is because the key is generated using like this 001 in the front. This is part of what's known as like the server ID. So when you start up tlp-stress, you can actually run multiple tlp-stress instances, and each one you can give an ID to, and then you'll know where the data came from. The reason why that's nice is because there are certain cases where you may want to juggle, like you may need to keep track of something in memory. For example, like the lightweight transactions workload, you wouldn't want different nodes stomping all over other nodes doing lightweight transactions, because we're going to keep track of the state of certain variables within the workload itself. So it just makes sense where you can, and you don't have to do this. Like you could just skip it and who cares and whatever. But if you give different parameters to different stress instances, then you can end up with kind of like weird results that make it hard to understand what your benchmarks are actually doing. So you kind of want to avoid that. So anyway, definitely use the ID flag if you're going to run multiple instances. Pro tip. Okay, so I think that's it there. What else we got? Okay, so it looks like it's settled around this thing right here. See what this says. Yeah, so you can see here, like we're not doing a ton of I/O. Our requests are few and far between, which is good. You know, we don't want to do a ton of I/O. We want to do mostly. We want to be hitting the page cache, and let's see if we're doing it. Dicey. Why not? Thousands of requests a second, none going to page cache, seems off. I did this test, I ran this a few weeks ago on here, and it was really weird. Anyway, something else to look at a different time. Some of this is just the result of me like still fiddling with this environment, and I'm not 100% on it. Some of this stuff might not even be installed correctly. It turns out there's like some issues with BCC tools. Like you can see here, like there it is, doing just fine. I don't know. Anyway, so I guess I'm gonna wrap this up now. We've got a whole bunch of stuff from tlp-stress. So anyway, hopefully you've enjoyed this. There is uh, there's a lot in here. Um, it's really powerful, and I think the thing to keep in mind is that this benchmarking tool is used to benchmark some of the biggest Cassandra clusters on the planet. Um, it's been standardized on a lot of places. It's popular. It is not as flexible through configuration as tools like NoSQL Bench. I should probably do something where I take a look at NoSQL Bench, but to be honest, I don't know it that well. I've heard a lot of good things. It's a super powerful tool, but it's just not how my brain wants to work. Um, so get anything on here? Look at that. Why is it just showing up once? Strange. What is going on with Page with cache stat? Maybe it's broken in this newer version of Ubuntu that I'm using. Anyway, benchmarking, fun times. If you are using tlp-stress, definitely leave something in the comment. And if you are, if you're interested in learning more about tlp-stress, learning about Cassandra benchmarking, and just learning about how to use Cassandra properly, or how to be the best at running Cassandra that you could possibly be, I am going to be starting. I am starting a training workshop in April, and I am taking only 20 students to start. We're going to run the first session with 20 people. It's going to go for 8 weeks. Really excited for this, and definitely drop me a note if you're interested in joining. People on my mailing list are getting priority access, so if you are interested, join the mailing list. An email is going to go out this week, and folks on the mailing list will have the opportunity to sign up for training and get trained on, you know, how to be awesome with Cassandra. So yeah, hopefully I will hear from you, and I'll talk to you soon. All right, bye everyone.